Let us start by importing Python libraries. We'll be making use of three libraries, PyGame, Random, and Time, out of which PyGame is the most important one. With the help of PyGame module, we'll be creating a game window and we'll be interacting with it using our keyboard and mouse. In the next step, we'll initialize the PyGame environment with pygame.init and shut down the PyGame environment with pygame.quit. Whatever the code that we write to build the game should be inserted between these two function calls. Our next task would be to create a game window. To create a game window, we need to decide on the width and height of the window. In this case, I'm going to consider these dimensions as 400 and 400. Now, we'll set up the game screen with pygame.display.setMode function and give the width and height combined as a tuple as an argument to the function. Then we'll give a title to display on top of the window by calling pygame.display.setCaption function. And the title would be the snake game. Now let's stop it here and run the program. We'll run the program by typing in python snake.py. You can see that the window has appeared and disappeared immediately. This is because we did not really write anything that could result in keeping the window up for some time. Let us write an infinite loop to take a look at the window for a longer time. Now we can see the window with dimensions 400 and 400. However, I cannot close the window because I did not write what to do if I select the close symbol with my mouse. All the inputs that we give to the game are called as events, and it is our job to tell the Python interpreter what to do in response to these events. Let us handle the event of closing the game window. We will write the code inside the while loop itself. We'll get the events by calling the function pygame.event.get. This function returns a list of events that occurred at a particular instance of time. We'll iterate through the events list and check if any of those is the closing window event. We can write the condition as pygame.eventType equals pygame.quit, where pygame.quit is associated with closing the window. And then we'll copy this line and put it in here and exit the program by calling quit function. This means that whenever we close the window, the game is going to exit. Let us see if it works. Python snake.py. We got the window and I'm going to click on close. Yes, it worked. Now let us proceed by putting a snake with a body of length 1 unit on the window. Before doing that, we'll have to define the initial coordinates of the snake. We'll name these coordinates as x and y, which are equal to 200 and 200 respectively. Next, we'll define a function to display the snake on the game screen. We'll name the function as snake. We'll consider the shape of the snake as a rectangle. Therefore, we'll call the function pygame.draw.rect. The first argument would be the game screen. The second argument is the color of the rectangle in RGB format. We'll paint it with white, which is 255, 255 and 255 in RGB format. The third argument is a list of 4 items, where the first 2 items are the upper left coordinates of the rectangle, which are x and y in this case. And the next 2 items are the width and height of the rectangle. We'll take them as 10 and 10. This means that 1 unit of length of the body of the snake is equal to 10 units on the game screen. After every change, we'll have to call pygame.display.update. We'll call this function inside the while loop. Now let us run the program. Python snake.py. There you go. We have a small rectangular box, in fact a square, with a width and a height of 10 units. Let's close this and go back to our code. Now we need to define how much distance the snake can move on the x-axis, which is leftward and rightward movement, and how much distance it can move on the y-axis, which is the upward and downward movement. For this purpose, we'll define 2 variables, delta x and delta y, and initialize them to zeros. We have to remember that these values should only be multiples of 10 because we're considering that 1 unit of the body of snake is actually 10 units on the game screen. So if the snake has to move 1 unit to the left, that means the rectangular has to move 10 units to the left on the game screen. Let us use delta x and delta y to update the coordinates of the snake. X equals x plus delta x and y equals y plus delta y. As the variables x and y are initialized outside the function, we'll make them global. Now we'll run the program to check if there are any errors. Yep, we're good. Let's close the window and go back to our code. Now let us define the keyboard events. We usually play the game by using the arrow keys in order to direct the snake to move in a particular direction. Let's handle the keyboard event. The event type of keyboard event is PyGame.keyDown. And among all the keys, we'll be handling our 4 arrow keys, starting with the left key. Whenever we press the left arrow key, the snake has to move to the left, which means that delta x has to be changed to -10. -10 indicates that the snake has to move 10 units towards the origin on the x-axis, as the origin will be at the upper left corner of the game screen. Delta y becomes 0 as there need not be any movement upwards or downwards. The next one is the right arrow key, which means that delta x has to change to +10 and delta y should become 0. Next, the up arrow key, where delta x becomes 0 and delta y is changed to -10, which means that the snake has to move towards the origin on y-axis. Finally, the down arrow key, where delta x is 0 and delta y is +10. If any other keys are pressed, we do nothing. Therefore, in the else part, we simply write continue. Let us run the program. I'm going to press the right key. Oops, that was swift. Let us go back and change something. We'll call the snake function after every keyboard event and we'll comment this line for now. This means that the snake can move only in response to the keyboard event. Let's run it again. I'm pressing the arrow keys right now and we're able to notice the movement of the box at every key press. But we can also see that it is leaving trails on the screen. It should appear as if the box is moving from one point to another. To make it appear like that, we need to clear the screen before every update. Let's go back to our code and update the snake function. Here, before drawing a rectangle, we'll clear the screen. This can be done by calling the function fill. And we have to specify a color to fill the screen with. As our background is black, we'll have to fill it with black, which is 0, 0 and 0 in RGB format. Now let's run it again. I'm pressing the arrow keys and there are no trails this time, only one single rectangular box is moving. There is one more problem in here. When the snake reaches the end of the screen, it should appear from the opposite side, but here it went away towards the right instead of coming out from the left side. Therefore, we have to see that the x and y coordinates are within the dimensions of the screen. Let's go back to the code and update x and y coordinates. In order for the coordinates to stay within the dimensions of the game screen, we perform the modulo operation. In case of x coordinate, it is x plus delta x modulo width, and in case of y coordinate, it is y plus delta y modulo height. Let's run the program and see how it goes. There you go, it is working. Now what we have to do is that we have to let the snake move even if there is no keyboard event like in the actual game. To do that, we'll go back to the code and write a condition if not events, and then we'll uncomment this line. This means that even if there is no event, the snake function will be called and the position of the snake will be updated automatically. Let's run the program. I'm going to press the right key. It's pretty fast. That is actually the speed of the while loop. We need to slow it down a bit. To do this, we have a utility called as clock in PyGame. Let's create a clock object by calling the function pygame.time.clock. We will use this object inside the while loop to set up a frame rate. We'll write the function clock.tick, which takes in the frame rate as an argument. I've experimented with different frame rates before and I have found that 10 is a good one. I also encourage you to experiment with different values. Let's run the game now. I'm going to press the right key. Yes, the speed is okay now. Now we'll change the initial value of delta x to 10 so that we don't have to press any arrow key to start the game. We'll run it and see if it's working. Yeah, it worked. Now if you observe the movement of the snake, you can see that the snake is able to move backwards. But in the real game, the snake should be able to turn only in 3 directions and not backwards. Let's go back to the code to correct this. We'll add an additional condition to check if the previous direction is opposite to the direction of the current key. We'll only update the values if the previous and current directions are not opposite to each other. For the left key, we'll check for the direction of the right key, that is delta x not equals 10. We'll update the new delta x only if the condition is satisfied. Similarly, for the right key, it is delta x not equals to minus 10. For the up key, it is delta y not equals to 10. And for down key, it is delta y not equals to minus 10. Let's run the program. Now I'm not able to move the snake backwards. Right now, as we are comfortable with the movements of the snake, let us jump to the next big step, which is to position the food. Similar to the case of the snake, we should also define the x and y coordinates to place the food on the game screen. Therefore, we'll initialize 2 variables, food x and food y. But what should these values be initialized to? In actual game, the location of the food is completely random. Therefore, we need to assign random numbers to x coordinate and y coordinate of the food. This is where we use random module in Python. We'll call the function random.randRange and we'll define a range of 0 to width for the x coordinate. But we should also keep in mind that the generated number should be a multiple of 10 as it needs to be associated with the snake. To convert any number into a multiple of 10, we'll perform the floor division by 10 and then multiply it again with 10. We'll copy the same thing for y coordinate and replace the width with height. Now we'll draw a rectangle in the snake function by calling pygame.draw.rect. We'll give the arguments game screen, a red color whose RGB values are 255, 0 and 0, and then a list of 4 values. The first 2 items are food x and food y, and the next 2 items are 10 and 10. Let's run the program now. Yes, the red colored square that you see on the screen is the food. Now, if the snake eats the food, it has to grow in length. This means that length of the snake can be more than 1 unit. Therefore, we need a list to store the coordinates of each unit of its body. Initially, the length of the list should be 1, as the initial length of the snake is 1. Let's define a list named as body list, which stores the initial coordinates of the snake in the form of a tuple. Then we'll go into the snake function and add a for loop to display the rectangles for each and every element in the body list. We'll replace x and y with I and j. Let us see if the program runs without errors. Yes, it's working fine. Let's go back to the code. Now, to increase the length of the snake, we'll append every updated set of coordinates to the body list. As every new set of coordinates is appended at the end, it means that the first element in the list is the tail of the snake and the last element is the head of the snake. Let us run the program again. You can see that the length of the snake is increasing. When the snake meets the food, it should grow in length, and when there is no food, the length of the snake should remain constant. Let us handle both the conditions. If food x equals x and food y equals y, which means when the head of the snake comes in contact with the food, a new set of coordinates should be formed for the food, and these coordinates should not be part of the body list. Therefore, we'll write a while loop in such a way that as long as food x and food y are not present in the body list, a new pair of coordinates should be generated. To generate the new coordinates, It is the same random number generation code that we used before. Now, in the else part, for the length of the snake to be constant in the absence of food, we need to remove the first element in the body list. That is, when one pair is added to the head, the pair at the end should be removed to keep the length constant. To remove the first element, we use delete body list of 0. We'll also make the food coordinates global as they are initialized outside the function. Let's run the program and see how it works. Yes, it is working fine. But is it over? No. We have to write the game over handling code. Let's go back to our code and define a variable named GameOver, which is initialized to false. But when does the game get finished? If the snake clashes with its own body, which means the newly updated coordinates x and y are already present in the body list. Let's get into the snake function and write the condition if x and y in body list. If this condition is true, we'll update the GameOver variable with row and we'll return to the function call. Let's also make GameOver variable global. Now, when the GameOver variable is changed to true, the while loop should be broken. Therefore, let us get into the while loop and check for the condition. If GameOver, we quit the game by calling PyGame.quit and then quit function to exit the Python program. Let us run the program and play for a while. I'm going to clash my snake. Yep. Now the game is over and the program has exited. But I want to display a message on the game screen that says game over for about 10 seconds before closing the window. To do so, we'll first fill the screen with blank. And then, in order to display a message, we should define a font. We'll create a variable named font and call the function pygame.font.sysfont, and we'll give a font style as the first argument. There is one font that I have found. I don't know how to pronounce this thing. The second argument is the font size. I have found that 25 is a good font size. We'll come back to the while loop and define a message using that font, a message that says game over. We'll call the function font.render with our message as an argument to it, and then we'll define the color of that message. Let's consider white for this, which is written as 255, 255 and 255 in RGB format. Next, we'll put this message on the game screen by calling the function gamescreen.blit with message object as the first argument and the coordinates of the upper left corner of the message. I found the coordinates width by 3 and height by 3 as a good placement on the game screen. Then we'll update the screen by calling pygame.display.update. Finally, we'll use the time module for the program to sleep for 10 seconds in order to display the game over message for 10 seconds before the exit. Now let's run the program and play it for a while. There you go, the game over message, which is going to last for 10 seconds. We are almost done. We just have to put a scoreboard on the screen. We'll define the score as the length of the snake, which means initially the score would be 1, and by consuming food each time, the score would be increased by 1. We'll define a variable named score, call the function font.render. We'll give a string that says score, and then we'll give the length of the body list as the first argument. Let us give a yellow color to this message, which is written as 255, 255 and 0 in RGB format. We'll display this message on the game screen by calling gamescreen.blit function with score as the first argument, and then we'll display this message in the upper left corner of the game screen, which is the origin. Let's run the game one final time. There's the snake, there's the food, there's the scoreboard, and then there's your game, which is done and dusted.